Everyone, so I'm Mark Craddock. I work for the United Nations, and I'm the technical director for the UN Global Platform. So we've been basically building a platform, a multi-cloud platform to support big data for 193 countries around the world, and we've been doing it for the last 2 years. So I'm going to talk about why multi-cloud, how do we get there, what's our strategy, and a bit about how we work in a very small team put together a platform for 193 countries over a very short amount of time. And then we'll get into a bit more, not as much technical details before, but about how we've got a big data platform. We've got 100 billion records of flight data. We stream 600 million records into the platform every day. And if we're lucky, I might even be able to give you a demo of that at the end. So here we go. Right, so back in 2014, the United Nations Statistics Commission set up a global working group with all the countries internationally to learn how to use big data to create official statistics. So in the private sector, there's lots of advancements, lots of statistics, but they're not official, so they can't be used for policy making or decision making. So the statistics community want to be able to use the same techniques to create their own official statistics. So the big vision for the platform is a global collaboration for harnessing the power for better lives. So it's a public good platform for all the statistical communities around the world, and it's for creating statistics to make a better planet, really. So we've got these 28 countries involved in the kind of core team and 16 UN agencies. And basically, one of the core things of the platform is the Sustainable Development Goals. I don't know if you're aware of them, but basically there's 17 big sustainable goals that all the UN sign up for. So number one is, remove poverty from the world by 2030. Remove hunger is number two. So these are big goals, and this platform supports the analytics to actually drive these statistics to help governments make the right decisions and the right investments to meet those goals. So the platform is about collaboration, sharing internationally. So at the moment, there's 193 countries. They all have to produce the same methods in the same way, but they all use different codes, different algorithms. So what we're trying to do is put one platform together so they can do it once, and they do it for the world, and they start sharing in collaboration and remove duplication. And that also makes these statistics comparably globally as well. So our approach is the hacker, the hipster, and the hustler. I don't know if you've heard of this before. So, your hacker is your coder, your technologist, and basically, using cloud, it's so much easier to produce something and get something up and running so quickly because you can log in, you can fire up servers. You don't need to wait 6 months for the IT guys to deliver that. Your hipster is your hustler. So your hustler is about kind of going around talking to people and promoting this platform. So we've been doing this across the world for the last couple of years. And, we've basically got a minimal viable team. So that is the team. Yeah, there's 3 of us, or there was 3 of us. And the goal was to build a minimal viable platform for the world. So there's key principles about, agile, iterating, configuration, showing people, getting feedback, building the platform. And using cloud, that's quite easy because it's quite easy to stand something up and shut it down. Most important, shut it down when you're not using it, yeah, or else your bills go through the roof. And consumption-based pricing. So by using these principles, it allowed us to build a platform for the world very quickly. And the 2 key, most important principles for the UN is leave no one behind. So we make sure we bring all the countries along so they can all get access to the platform and the data within the platform. And we endeavor to reach the furthest behind first. So the most challenged countries, we help them first and try to bring them all along at the same pace, or maybe spend a bit more time with them to bring everybody to the same position. So we use the platform business model. I don't know if you've actually done any research or looking at the platform business model, but there's a huge piece of work from the platform design toolkit, and it talks about how to build a platform. So it's about connecting consumer buyers with consumers, the Ubers and the Airbnbs, but what is it that makes them successful? What is it that makes them a platform? And what is it that makes them global? And the platform business model is what does that. So there's a huge amount of research and knowledge and education around that. And the platform business toolkit, I don't know if you use kind of business canvases to map internal process and stuff, but there's a set around specifically around doing platform businesses. So it's about how do you connect your buyers and your suppliers? How do you aggregate that into one place? How do you make it really easy for people to do this? How do you remove friction from that so it's so easy people don't think twice about it? So we've been working with the statistical communities, and we've been understanding what the challenges are so that they can share and collaborate together so we can save the planet. So I'll skip that. So, and the platform business model is the best way of building and developing that kind of evolution, because you put your platform in place, you have your buyers and consumers, they work together or they don't work together, but essentially, in the same way Amazon does this. So we see Amazon stand up some infrastructure or new services. People use that infrastructure, and I'm assuming behind the scenes they're analyzing that data. They can identify why is this service called Netflix consuming so much of our infrastructure? Because it's a really good service, it's meeting user needs. Why don't we go and do something similar? Yeah. And this is called ILC, so it's called Innovate, Leverage, and Commoditize. So you build your platform business, you let people innovate on your platform business, so Netflix and other services, Skype, and then you leverage that, and then you bring that into your platform. Your platform gets bigger, your platform gets better, and it's a continual evolution of your platform. And all your user research, all your effort, all your development is done by your existing customers on your platform. Then you leverage that and you put it into your platform, and your platform gets bigger. Now we do hear talk of Amazon eating their customers now and again, and they tend to do that because they use this kind of model, platform business model, which you can find online about the details about it, how it works. So our technology strategy. So we use Wardley Maps. I don't know how many people use Wardley Maps. All right, good. Yeah. So basically a Wardley Map. So there's 4 phases of technology. So it starts off in your Genesis phase, you get a custom phase, you get a product, and you get your services. So all technology goes through these phases, all data goes through these phases. So on your left-hand side is where it's kind of unique, it's novel, it hasn't been done before, there's high risk of failure. And on your right-hand side is utility, you don't think twice about using it, and you pay by consumption by getting your credit card out. So on the right-hand side, so this is quite old actually, this is about 18 months old, so I would say a lot of this stuff has moved to the right already. So on the right hand side is your cloud infrastructure. Now your big data analytics are over there. Your data pipelines, your data warehouses, the NoSQL databases, they're all cloud and they're all commodity services. So why would you try and build and develop them yourselves? So when we did this, and basically we said we're going to focus on this area. So for the statistic community, it's really important to understand the data provenance, where did the data come from, what's being changed to that data, how's it been changed, so you get kind of so it's repeatable, a repeatable analytical pipeline. Yeah, so you can repeat it because we need to do it again and again and again. So we've spent a lot of time around the kind of data, the pipelines, and the kind of data provenance, and also some areas I might talk about in a minute around multi-party computation and homomorphic encryption that allow you to encrypt data at source and still do calculations on the data while it's still encrypted, which sounds like magic, but it's true, it's possible. So this is our Wardley Map. So we decided to focus on this area, which meant basically for us, cloud is on the right-hand side. We don't need to worry about it. We don't need to test it. We don't need to prove it. There's hundreds of millions of people who are doing this already. They're already using cloud. They're already consuming services on it. We don't need to prove it. We don't need to spend a lot of time on it. We just need to get a credit card out, and we just need to buy it. So because this is a global platform, there is no one cloud that suits everybody in the world. So we've got 4. We've got Amazon, Microsoft, Google, and Alibaba because of geopolitical reasons. So the Chinese Statistics Office probably doesn't favor putting their data into the Amazon cloud. And we've also got some security issues. And when your cloud provider also has a larger market, so Amazon Retail, there are some providers of data to the statistical community that prefer not to put their data into their competitors' clouds. So we have to have more than one cloud, and that is really the main reasons for multi-cloud. It's not a technical decision. It's not about failover. It's not about stretching Kubernetes across 4 different clouds in case Amazon goes down for 30 seconds, next Tuesday. Right? It's about ensuring that we can keep the world happy, people can get access to the data, and they feel safe and secure with the data that they put into the platform. And this is our Wardley map, and there's a newer version of this. So actually, I'm presenting at Map Camp in October, so there'll be a new version of this, and we'll go in. I'll get 20 minutes of actually about the map and how we do it and how we get into it. And there'll be a bit more about these cryptography techniques that we're working on. So, and if you're interested in Wardley Maps, so the UN now have produced a handbook for all the statistical offices about how to use Wardley Maps to create your IT strategy, and it covers, why cloud, because it's a commodity, more about machine learning, big data, where should you get these services? You should get them from the consumer, from the cloud, and there's a handbook for that online. And this is what our small team has done over the last year, pretty much, because we're using cloud, and because we're consuming commodity services, and we were focusing our effort on the kind of unique and novel and stuff that you can't really buy anywhere else. We have to build it ourselves. Another thing we've done, because we've got 4 cloud providers, because we've got projects all over the world, we've done some work where we take the billing data from each cloud provider, and we've got a tool that allows us to aggregate the bills not only in Amazon, but across all cloud providers. So some of the platform is funded by philanthropists, so we can guarantee and audit where data comes, where the money comes from, where the money's spent, so we can pretty much give, using the bill of data you get from the cloud providers. And Amazon's the kind of leader in that area, where the money's spent, which region. So if we get some money to run a project in Africa, we can pretty much guarantee that that money was spent on cloud infrastructure in Africa for that project. And some rules, and because we're global and because we have multi-cloud, we can also decide where to put our workloads. So we can basically put our workloads in the cheapest region. So at the moment, a lot of it's in Virginia, in Oregon, in Amazon, because it's the cheapest region. Germany's 50% more expensive than Oregon. So it's a global data set, so we'll put it in Oregon. It makes sense. Yeah? And because we've got the billing data and we can analyze that, we can actually make decisions about this project costs this much, so we can use that data for another project that may be similar, so we can make kind of guesstimates about how much the similar projects will cost. So quickly on the privacy technique, so multi-party computation, fully homomorphic encryption, zero knowledge proofs, trusted execution environments, and differential privacy. So the first 4 allow you to encrypt data at source and still do calculations on that data. So for our platform, that means we can take more sensitive data that's encrypted at source, put it into the platform, and still do statistical calculations on that data without decrypting it. And some of these techniques are already used by Google and Apple on your iPhones and iOS, because they use it for doing building the machine learning models for predictive text. And differential privacy is about when you publish data, it adds a bit of noise to that data, so it makes it mathematically impossible to link that data to any other. So if we had a data set of all our heights, when we publish that data, your height will be slightly taller or smaller, and so you won't be able to link it to any other data known about you related to height. But if you did a statistical calculation on this data, saying what's the average height, you would get the right answer. So that's kind of differential privacy. And again, our teams produced a handbook on that. So the slides will be available. You can have a look at that. But it explains all the different techniques. And we also use Wardley Maps to explain where they are, what they're good at, what they're not good at. And some you need to think about kind of privacy budgets. So you can, by making many calls to this data, you can actually try and work out what the data is, even when it's encrypted. So the interesting bit, so global big data sets. And we in the statistical community, they talk about big data, but they don't really have big data. So I think the census for the UK is about 4 terabytes, and in the statistical community at the moment, they talk about being big data, but it's not, is it? Unless it's got 1 billion in it somewhere, it's not big. Yeah? Anybody agree? Yeah? No? Right. Let's move on. Right, so for the statistical community, we collect data and we use data from many different sources to create official statistics. And generally, big data is not owned by the statistical offices, it's owned by someone else. So big retail organizations, telecoms, flight and ship data we'll see in a minute. So we can't assume we have access to that data. But in the UK, there is a law for the statistical Office of National Statistics can ask any private company for their data for purposes of producing statistics. And I don't think they've used that power yet, because most companies are happy to help. And the other thing about big data is the assumption, we should all make the assumption it's going to be in the cloud in the future. So if we do our Wardley Map, we can assume the best place to put big data is in the cloud, because you've got the power to compute and storage and cheaper storage. Some people will take a long time to get that to that place and that journey. And the other thing is a data mesh architecture. So Martin Fowler from ThoughtWorks, there's a nice paper on data meshes. But basically what we try to do, what we've done in the past is try and collect all this data, put it in a big data lake. We don't really understand the data because it's not our data. We try to make it accessible to people when they don't really get anywhere. So there's kind of hit and miss if the data lakes work in organizations or not. But the data mesh is about, well, actually, let's turn data into a product or service. So the data owners are responsible for the data. They publish it via APIs. That's easy to consume. So then it's a case of pulling the data from those APIs as opposed to trying to own it and manage it and look after that data yourself. So it's a kind of different architecture. So that's the kind of architecture we're going for in the platform. But we've got 193 countries with their local and regional data sets, plus we've got some global data sets. And there was a report recently from Gartner that says, big data is cloud, put it in cloud. I don't quite agree that only legacy and special requirements should keep it where it is. I think, if you've got big data, put it in the cloud, because, if you look at the advancements in the last year about the data analytic tools and the capacities and the capabilities there, it's improving so much. And also, if we look at, if you want to do machine learning, no cloud, no AI. Yeah, so because you need that compute and you need that kind of processing power available to you. So in our platform, we have ADS-B records. So that's every flight as a radio transponder transmits via radio frequency where it is, where it's flying, some data about it. Has it got propellers? Is it the military? Yeah, how high is it? And all this data is open data because it's just broadcast via radio frequency. And there's a few companies out there that kind of collect this data, aggregate it. And for us, that's been streamed to the platform. So we have 100 billion records of flight data in the platform that's used for analytics around official statistics. So it could be tourism, it could be carbon emissions. And also we've got the same for ships. So ships over a certain length have a similar radio transponder, and they broadcast where they are, how long they are, if they're freight, fishing. And again, we get that data into the platform. So we get over 40 million records a day into the platform, streamed into the platform. So I've just said that. And on the flight data, so there's about 10,000 flights in the air. They broadcast every second of where they are. So there's the receivers around the world. They collect all this data. All that data gets streamed to the platform. So the aggregated data is 600 million records a day. It's a lot larger than that, the actual data, because multiple receivers pick up the same radio frequency because it's, obviously covers a big area. We've also got satellite imagery in the platform, but when I say it's in the platform, it's in the cloud, so it's just sat next to us, so we can consume it and use it whenever we want. And on satellite imagery, we're trying to go cloud native, and for the geoprocessing satellite imagery, statistic organizations use satellite imagery to identify features, land use, water use, fishing, agriculture, crop yields. So there's a lot of satellite imagery used, and really in the kind of research I've been doing, some of the best stuff around processing satellite imagery is from the geo intelligence community. So the guys that actually use satellite imagery for intelligence services. And the National Geospatial Intelligence Agency in the US have published a lot of open source tools for processing geospatial information. And we use open standards in the platform. So you've got COGS, which is allows you to take an image, satellite image, but when you combine them together in the different layers, you can have one image. In the new standards in HTML, that allows you just to pull down the bit of image you need. You don't have to pull the whole image down to process it. Then you've got stack, which is the catalog. So that's a way of seeing those images. as a kind of catalog, so it's easy to consume in geoprocessing applications that are cloud native. So these are all the kind of services we put together. So we've got our method service, which is actually basically Algorithmia. So that allows us, which is running on top of Amazon, and that allows us to take any piece of code, publish it as a method into the platform, and it basically wraps an API around it, and allows us to scale up and consume it as an API. And it also allows us to do the same with machine learning models as well. So we can take a machine learning model, deploy it, do the versioning, and not only can we deploy it across Amazon, we can deploy it across Azure and a Google as well. And in the future, we expect that to be kind of transparent of which cloud and which region we're in. We've also got a marketplace, and everything we're doing is kind of AI, ML ready. So our location analytics service, so the stack we use is GeoMesa, or GeoMesa, as they say in the US. So most of it's open source, so we use Apache NiFi. I don't know if anybody's used Apache NiFi before, but Apache NiFi, one at the back. Apache NiFi was developed by the NSA, and it was designed to collect large amounts of information off the internet and store it for analysis. So it scales, it processes millions of records a second, it uses clusters, and it can just collect data and move it around pretty much anywhere. So we use Apache NiFi for collecting data for statistics, and also some of our data pipelines and moving it around. We use Kafka, HBase, and Spark for the actual data in the database. And when you process geospatial information, so when you've got 100 billion records in a database, and you want to start doing sort of analyzing that and looking at a particular bounding box, or doing kind of queries, traditional databases are pants. Yeah, they really don't process this data very well, and there's some new database, and basically they have to run on the cloud because they're using the scale in the cloud and the power of cloud, and kind of Kafka and Spark. We also used Jupyter Notebooks for doing analysis and writing queries, and GeoServer is used for publishing the kind of satellite imagery. And there's a report there from the DSTL, which is the data science arm of the MOD, and they did some benchmarking of these different open source stacks and published details of importing like 1 billion records and then doing an analysis of 100 million and how long these queries take to run. So in a traditional database, they might take hours to run, but using tools like GeoMesa, they run in milliseconds and seconds. So there's a huge amount of ability to run queries faster. But you can only do that if you're sitting in the cloud and you're using those kind of open source tools. So the stack looks like this. So we collect the satellite imagery, the flights from the radio receivers. Some of this is actually on in a co-location at the moment, which is not ours. This is the data we've received from the third party, from ADSB Exchange. And that data gets fed into our stack, which is in Amazon in the cloud. We put some of the data in Redshift for running queries. And I think we need to look at, is Redshift the right stack for that? So if anybody's got any ideas about that, come and talk to me after. And we also archive that data in S3. Sometimes we've had a small outage and we need to go back to the archive and replay that data into the platform so we don't miss any data and get any gaps in the data. And the other end of that is the kind of GeoMesa stack. So Apache NiFi has a data flow to collect a TCP stream of data that flows in. So we get a constant flow of 10 meg pipe into the platform constantly, 24 hours a day. That gets split into Kafka, which is used for doing real-time analytics on the data, and then it gets put into HBase for storage, and then doing archives and historical analysis of the data. And then we use kind of GeoServer, which is the geospatial tool for presenting and looking at that data in kind of real time and also archiving. And we use Spark and Jupyter for doing analytical queries against that data. So there's the NiFi flow, and it's a bit small, but I'm sure we can probably put that on GitHub somewhere, so you can, if you're really interested, you could get access to that. But you can see it's just a few connectors. So Apache NiFi allows you to take processors, they're called. So it could be get some data, convert it from JSON to CSV or CSV to JSON, and there's about I think over 200 different processors now in version 1.9, I think. but it allows you to collect data from Amazon, from Google, from Azure, in and out of HBase, Accumulo, do some transformation of that data, move it around, and it's open source and it's free, and there's quite a good community around that, and it's used quite a bit in some public sector organisations. So I think the Home Office use it along with some others, and that's what we use to kind of collect and move data around in the platform, and that's doing 600 million records into the platform, just the flight data, 40 million records a day of ship data, and we've also got another feed now going into the platform, which is about 80 million. So I know there's a lot of data coming into the platform, going through NiFi, and one of the things that NiFi does do, it allows you to, if something breaks, it'll queue the data up, and then you kind of repeat, and you can kind of repeat that flow and not lose the data. And it also allows you to build quite complex error loops as well. So if the data does fail and it doesn't get where it's supposed to go, you can either store that and archive it, and then allows you to replay that kind of data later as well. So it's very powerful. And it also gives you the data provenance as well. So any piece of data that goes through NiFi, you can look at the provenance record, and you can see where it came from, what was applied to that data, and kind of where it is in the flow now. So it's very good thing. So that's the kind of analytics service we've been talking about. That's kind of the visualization, what it looks like. So this was, so all the green dots are ships, so you can see the kind of shipping lanes. The blue dots are flights. The last time I did a presentation similar to this was out in Shanghai. So that was the regional flights around Shanghai airport, and that was the kind of cargo ships in the area. But I think what I might actually be able to do, just to prove all this is actually real, and nothing better than a live demo. Right, if I can just get the mouse to go down. Not that way. There we go. Right, so this is the live tool. This is a $200 Chromebook using the Wi-Fi here. And when I was sat down there earlier, I just did a query of the last 12 hours of all the flights in and out of Heathrow or around that area. So we can see the platforms collecting this data, making it available for analysis. So the statistical community now can use that data to do some analysis of flights, carbon emissions, tourism, and that's kind of live, and it's most importantly that because the platform is for everybody in the world, that we do use something like a Chromebook, because we need to make sure we leave no one behind, and we bring the furthest up nearer to the actual goals. Thank you. So.
Wow, wow, wow. What an amazing talk. I mean, come on, another round of applause. I've actually used Wardley Maps myself, and a quick plug for Wardley Maps. There's a map camp, isn't it?
Map camp in October. Mid-October.
Yeah, I'm going to that. I'd highly, highly recommend it to anybody, actually. So it's one of those things that not many people have heard of, but it's actually growing massively, isn't it?
Yeah, yeah.
It's where we're in it. Just like Amazon was a few years ago, Wardley Maps is really gaining traction. So get in there early. Any questions?
One of the things you said was about, instead of data lakes where the owner becomes responsible for giving the data, does that mean they can quickly revoke the data?
Yeah, so with a data lake, you collect the data and you kind of have ownership, don't you? And you're responsible for that data, so you have more responsibilities than if you were consuming that data via an API. So this data we get streamed into the platform now because it comes via an API. At any point, they could switch it off if they wanted to, but because it is looked after them and it is managed by them, the data's in an easy format for us to consume, which is why it was relatively easy to stream that data into the platform.
I was just thinking, if a country suddenly says we don't want to give this data off,
Yes, which
You've
is a
lost that
benefit
data.
to that country and not
Negative
anywhere else.
to it, yeah.
But we need to give we need to give people the power, empower them to make those decisions, but also by doing that, it does make it easier for us to consume that data as well.
Thank you.
Thank you very much for the presentation. Because it's really fancy geolocation, how are you doing those geolocation calculations? Maybe is it in a bounding box or something like that? What is behind that?
So the short answer is have a look at that report done by DSTL, because they've got loads of sample queries that are possible. So some of the queries by using GeoMesa, it doesn't matter what the query is really. If it's a circle or a bounded box, because of the way it works, it can handle those kind of queries quite easily. But that has a huge impact on traditional databases when the types of query you try. But the report from DSTL, I think it's got about 6 different use cases and query types, and it shows you how those 6 query types perform under the different. It tells you how they perform basically using the different open source stacks and some commercial stacks as well, databases.
Yeah. And those geolocation points, where are they stored? In which database or?
Yeah, so the data streamed in. It's all stored in Hadoop. And it's actually stored in Amazon Hadoop, which is actually using S3 as a storage. And I think there's maybe 50 gigs of data coming in every day into the storage.
Okay. Thank you very much.
Thank you. Question about this. How many metrics or how many fields or parameters do you get about each flight when it comes?
Yeah, so that's a standard format. So the ADS-B format is defined internationally. So I think there's about 20 parameters. So it's the plane, the altitude, the direction, the heading. And then some data about how many engines has it got? Is it a jet? Is it prop? So I think it's about 20 different fields.
And following that, do you or someone else keeps the data of the passengers who are flying on?
No, so we don't get any personal information at all.
So MS-370 or whatever that flight was lost somewhere or shot down. So would you have that data on the system?
If a flight was broadcasting via its transponder, then we would have that data. But so would sites like FlightAware and Flight Radar as well, because it's open data and broadcast. So anybody with a capable receiver could receive that information.
Thank you.
Hey, how or who decides what data you start ingesting? Because these are some pretty different data sets. That are a committee, or do people get together and decide we want to start getting flight data today, so let's go about doing that?
Yeah, so within the statistical community, it's there's obviously a very strong ethics. So for the Office of National Statistics in the UK, they do produce there's a ethics board. And there's documentation on their ethics and decision making. Within the UN, it's very similar. I think there's 9 principles around statistics, and it talks about what data, and basically the data is used for official statistics. So we wouldn't go and produce like a flight radar site, and we wouldn't use the data for anything else. And we would only use the data for official statistics, and we only ever really publish the answer. So we would publish what's the carbon emissions around Heathrow, for example, if someone wanted that statistic, but we wouldn't publish any of the data that we collected to produce that. But the statistical community makes the decision on the data sets they want to use to meet the outputs, official outputs. So the Cabinet Office may ask for a particular statistic, or then there's some standard ones they have to produce by law, like GDP. So the statistical community identifies the data they need, and then they go out and try and collect that and get it from different sources.
Sorry, my English is not that great, but I'm originally from Somalia, and probably we don't have some sort of control for maritime. And all the ships that go through there, if Somali government wanted to find out how many ships went through there, how would you provide the data?
So we can only get the data if the ship is broadcasting that data. So if they've got the transponder on, which they should do by law. And I know there's some work in the UN, not related to the statistical community of producing official statistics, but they are using data from AIS. So the ship should broadcast where they are, but they're also combining that with satellite imagery. So if they can see, because generally large fishing vessels, they're large and you can see them on satellite imagery. If you can see a ship in the satellite imagery, but you can't get a corresponding AIS data for it, why is it there and why is it not broadcasting why it's there? And then people can carry out some investigation around that if they want. Yeah.
Thank you.
Any other questions?
Actually, that was my question. A few years ago, I helped the UK Satellite Applications Catapult in Harwell build a dedicated cluster to analyse ship movement data. And what they were doing was looking at ships which were illegally fishing in the Antarctic. There are areas of the world which are marine nature reserves, and you can't fish in them to allow stocks to recover. And what ships would do would do not just track ships into these areas, they would turn off their transponders and do dodgy things, and they were using AI to try and figure out what these ships' suspicious patterns of behaviour. And I mean that would be one application for it. And with your platform, you wouldn't even have to build that. You could now start.
Yeah.
To work
Our platform is for producing official statistics. It's not for operational use. So we could tell you how we built it, and we could show you how we built it, but you wouldn't be able to use it for that purpose.
Okay, final question.
I wondered in terms of the, is that on? Yeah. I wondered in terms of the actual ingestion rate and the increase in volumes of data that's going to occur over the next few years, whether any consideration has been given or actually is actively given consideration to in terms of GPU processing to bring the actual number of servers down and to make the whole scenario more efficient in terms of large data processing.
Yeah, so we're about to do an AWS well architect review to look at that, to see if we can make it more efficient. And we're not quite sure if we need Redshift, and we're going to look at that kind of pipeline that comes in. See, it may be, but because we need to be multi-cloud, it's not something we could say, well, let's use Lambda to process that kind of feed, because it wouldn't be suitable.
Well, I mean, I'm talking about things like Kinetica GPU based, so NVIDIA graphics card processing, whereby, you're talking things like the geolocation and the algorithms used. Everything comes down to triangles, essentially, and graphics cards are brilliant at that sort of stuff.
So the ingest is Apache NiFi, and that will scale. It's not even big what we're doing there. It's not.
But in terms of the actual data analysis,
but the actual
analysis,
there is another open source company that is using a similar stack, but it's based on GPUs, and I can't remember the name, but I will remember it and I will tweet it later. Yeah.
Well, thank you so much. Another round of applause for Mark Craddock.